Welcome to this tutorial on deploying a smart contract on multiple blockchains with the same address using Hardhat. In this video, we will walk through the entire process step by step. We'll start by setting up our Hardhat configuration to connect with different networks, including Ethereum Sepolia, Polygon Amoy, and Binance Smart Chain Testnet. Then, we'll write a deployment script to deploy our contract across all these chains while ensuring it retains the same address on each. By the end of this tutorial, you'll understand how to set up a multi-chain deployment workflow, verify contracts on block explorers, and fetch blockchain data using custom Hardhat tasks. So, let's get started. Now I will explain you hardhat.config.js. The Hardhat configuration file is the backbone of our multi-chain deployment setup. It starts by importing essential dependencies, such as atomic labs/hardhat ethers, for interacting with Ethereum-based networks, .env for managing environment variables, and atomic foundation/hardhat verify for verifying deployed contracts. We then extract API URLs and a private key from the .env file to securely connect to multiple test networks, Ethereum Sepolia, Polygon Amoy, and Binance Smart Chain Testnet. A key feature in this script is the custom Hardhat task, named account, which retrieves the nonce, transaction count, and balance of a given wallet address on different networks. It initializes blockchain providers for each network using Alchemy Web 3, loops through them, fetches the required data, and formats it neatly for display. Finally, we configure the Hardhat network settings to enable seamless deployment. Each testnet is assigned an Alchemy RPC URL and the same private key, ensuring the contract gets deployed to the same address across all chains. We also integrate Etherscan API keys, allowing us to verify contracts automatically on Sepolia, Amoy, and BSC testnet block explorers. Here is our Solidity file code period. The Vault smart contract is designed to securely hold and lock funds until a predefined unlock time, ensuring that only the contract owner can withdraw them once the time has elapsed. It begins with the SPDX license identifier for open source licensing and specifies Solidity version correct 0.8.9. At its core, the contract has two state variables: unlock time, which stores the timestamp at which funds can be withdrawn, and owner, which holds the wallet address of the contract's deployer. The constructor takes _unlock time as an argument and ensures that the provided time is in the future. If the current timestamp is greater than unlock time, the deployment will fail. The deployer's address is then set as the contract owner. The contract features two key functions: deposit and withdraw. The deposit function allows anyone to send funds to the contract, emitting a deposit event to record the amount and timestamp. However, the contract does not impose access restrictions on deposits, meaning anyone can add funds at any time. The withdraw function enforces strict conditions for fund retrieval. First, it ensures that the current time has surpassed the unlock time, preventing premature withdrawals. Then, it verifies that only the contract owner can initiate the withdrawal. If both conditions are met, the function emits a withdrawal event, logs the amount withdrawn, and transfers the entire contract balance to the owner. This contract is useful for time-locked vaults, escrow services, and trust-based fund releases, ensuring that funds remain inaccessible until a predetermined moment while providing full transparency via events. Here is basic deployment script. The deployment script is responsible for deploying the smart contract on the configured blockchains. It defines an async function called main, which first initializes the vault contract by fetching its factory using ethers.getContract, factory open parenthesis, vault, close parenthesis. The contract requires a constructor argument, unlock time, which is set to a future timestamp, 1,745,236,800. This ensures that the vault remains locked until the specified time. After initializing the contract, it is deployed using await vault deploy unlock time, and we wait for the deployment to be completed with await vault deployed. Once the deployment is successful, the contract's address is logged to the console, making it easy to track on different block explorers. To handle any unexpected issues, the The script includes a catch block that logs errors and exits the process if something goes wrong. Since we are using the same private key across all networks, the contract will be deployed at the same address on each blockchain, ensuring consistency across different chains. The main thing is nonce. For deployment on same address across different networks, we will ensure that nonce on each network will be same. So for that, we will create a new account on our MetaMask wallet, because new account doesn't have any previous transaction history, so the nonce will be same for all networks. After that, we will run the script to see our nonce on all networks. We will run the script by this command. npx hardhat account, address your wallet address. See, here is our output. The nonce is same for all networks. Then we will compile our Solidity file code with this command. npx hardhat compile. Our code is now successfully compiled. Before deploying our code, we will first see our balances on each network. Now we will deploy our vault contract. For deployment, we will run 3 commands. npx hardhat, run scripts /vault deploy.js-network, Sepolia npx hardhat, run scripts /vault deploy.js-network, Amoy npx hardhat, run scripts /vault deploy.js-network, BSC testnet. Okay, let's see output, then by running these commands. Here is the output of deployed contract on Sepolia. Here is the output of deployed contract on Amoy. Here is the output of deployed contract on BSC testnet. Okay guys, we have deployed Vault contract on same address on Sepolia, Amoy, and BSC test networks. Now we will see our deployed contract addresses on Sepolia Etherscan, Amoy Polygon Scan, and BSC testnet scan. Okay guys, that wraps up our tutorial on deploying a smart contract on multiple blockchains with the same address. We covered everything from setting up the hard hat configuration, writing a deployment script, and understanding how the Vault smart contract works. By following these steps, you can deploy your contracts seamlessly across multiple chains while maintaining a consistent address. This approach is essential for multi-chain dApps, cross-chain asset management, and interoperability in blockchain ecosystems. If you found this tutorial helpful, don't forget to like, share, and subscribe for more blockchain development content. Let me know in the comments if you have any questions or if there's a topic you'd like me to cover next. Thanks for watching, and happy coding. Blast off.